Ladies and gentlemen, welcome. Today we talk about friction, or lack thereof. Big idea to start everything off is that when we have friction is based off of two things. One is this coefficient. This is mu. You're welcome. And N, normal force. The harder you push down on the surface, the more friction you're going to have. So I might have a piece of wood and some sandpaper, but if it's a heavy piece of wood and sandpaper, I'm going to have more friction. But this mu here is the interaction. It's like a scale factor. Let me show you a couple of values. Good to see you wrote that down. A couple of values. Notice we have two words. Kinetic means sliding, and static means exactly what it says, non-sliding. And so you'll see this in two forms, UK, which is kinetic. So if you look, rubber on dry concrete is 0.8 when you're sliding, so that'd be like your tires, skid marks on the ground. 0.9 is when you don't have skid marks, your tires are still gripping onto the ground, not moving. So if you look at some things, Teflon is the stuff that you have on your pans. It's basically zero, not much friction. But if you think about a car tire, I have a lot of friction. So, alright, we're going to do a couple of problems. First one, we give you the friction force, and so anytime you're given a problem, start by drawing your force body diagram. Normal, weight, you pull with 2 newtons of force. Well, your normal force is 30, your weight force is 30, because it's not on an incline or anything like that. So the first question is, what is the friction force? Well, it tells you that it just breaks free. So if it just breaks free, it's okay to say that your friction also has to be 2 newtons. Okay. Friction is mu times normal. 2 equals mu times 30. Solve for mu, I get 2/30ths, which is a very small number, 0.067. There's no units because this is newtons over newtons, and it cancels, meaning I can have pounds, I can have any unit of force. Number 2, pull a 5 kilogram box with 20 newtons of force. Coefficient is this. What's the acceleration? Whenever you hear a question about the acceleration or time or velocity, you need to be thinking F net equals ma. And to do anything with F net equals ma, you have to draw your force body diagram. Normal, weight, hopefully you're stopping and doing these. I'll know, right? That's 20, and I have friction opposing the motion. Problem, I don't know how big my friction is. So the first thing I need to do is I need to find my friction. Friction is mu times normal. So friction is 0.22 times normal, which is 50 in this case, because the weight is 50, and the normal is 50. And so my friction force is 11. Now if I know my friction is 11 newtons, but I'm pulling with 20, my F net needs to be the difference, 9. So 9 equals mass times acceleration. Acceleration is 9/5 meters per second squared. Number 3. 4 kilogram block at an incline of 30 degrees with a coefficient of sliding friction. So it's sliding, it's not sticking, sliding, of 0.11. Determine the acceleration of the block. So here we go. I have a block on an incline. Try drawing this on your own and then come right back. And I have my friction going up the ramp, because if it's sliding down the ramp, I have to have friction going up. Now, whenever I have my weight force on an incline, I break it into its components. My two components are mg cosine theta and mg sine of theta. Once I know those two values, I'm going to need to calculate them at some point. Here's why. Well, let's just get numbers for them to start with. So mg cosine, I plug in my values and I get 34.64. I do mg sine of theta and I get 20 newtons. Now we're going to really look at how do I use these. Well, if I think about my question, determine the acceleration, I need to know my F net. To know my F net, I need to think about which way is my block accelerating. It's accelerating down the ramp, so I'm going to involve mg sine of theta. But think about what's opposing it. What's opposing it is my friction force. So I need to look at my friction, and I need to find out how big that is. Friction is mu, 0.11, times normal, 34.64, and so I get a friction force of 3.81 newtons. Now, if I think about it, to find my F net, I've got 20 newtons going down the ramp, and my friction is 3.81 newtons going up the ramp, and so I can do F net equals MA. My F net is the difference of the two, which is 16.19. My mass is 4. Solve for A. Get an acceleration of 4.05 meters per second squared. They're going to ask you questions about kinematics after this. They're going to also ask you questions about what happens if I make my angle bigger. If I make my angle bigger here, what changes? My normal force gets smaller. The ground doesn't have to push as much. If it doesn't have to push as much, that means my normal force gets smaller. If my normal force gets smaller, my friction gets smaller. And so I'm going to accelerate more and more and more.